Okay, so let's look at this example in terms of polar coordinates. So we want to remember that the sine of theta is equal to y over r if we don't have the unit circle, right? Sine theta is equal to y if it's a unit circle, but for any radius r, the sine theta is y over r. Now this says that r times the sine of theta is equal to 2. So I'm going to go ahead and substitute this piece, since that's the sine of theta. We have r times y over r equals 2. So the radius divides out, and we're left with y equals 2. And so that's a horizontal line 2 units above the polar axis, or the x-axis. So as a rectangular coordinate, that would be y equal 2. Now we're showing it on the polar, showing the rectangular plot on the polar axis. Okay, so I kind of overcomplicated this a little bit because I wanted to look at it in terms of the polar equation. Now let's just remember that we've got a definition that r times sine theta, y is equal to r times sine theta. So I can really just substitute y for r sine theta. So y is equal to 2. Okay, and we've got a similar situation here, but we know that a cosine of theta for some circle with a radius r, other than a unit circle, we're going to have the cosine of theta is equal to x over r. So let's take this and substitute cosine of theta. So we'll take r times x over r, and that needs to equal -3. So what we really got here is x equals -3. But again, if we remembered that our cosine theta is equal to x, we can just directly substitute x for the left-hand side, and we get x equal -3. So of course we've got a vertical line running through the coordinate -3 on the x-axis. Okay, so we can generalize what we looked at here. Since our sine of theta is always y, this is always going to translate to a horizontal line, y equal a for whatever real number a is. And then since our cosine theta is equal to x, if we see this, we can always translate that to a vertical line, x equal a. Okay, so now we're going to use these equivalencies to help us figure out the rectangular equation that corresponds to this polar equation. So one equivalency that we have is r squared is equal to x squared plus y squared. And we also know that x is equal to r times the cosine of theta. Y is equal to r times the sine of theta. And so we need to figure out how to tap into these in order to change this. So if I multiply both sides by r, then I get an r squared. And then on the right hand side, I would get 4r sine theta. All right, so substituting the equivalencies here, we've got x squared plus y squared. It's going to take care of that r squared. And then we got 4 times r sine theta, which is y. So this equals 4 times y. And now I'm going to set this equal to 0. So we would end up with x squared plus y squared minus 4y equals 0, and I have to complete the square to get the center of the circle. So come over here, we're going to have x squared plus y squared minus 4y, and then I have to take, remember, negative 4 over 2 squared to create a perfect square out of this. So I'm going to add, that would be negative 2 squared, which would be positive 4. So I'm going to add 4 to both sides. And now I've got a perfect square of y plus negative 4 over 2. So y minus 2 quantity squared takes the place of this, and x squared, and that equals 0 plus 4, or r squared is 4. My center of the circle is at 0, 2. And the radius squared is 4, so the radius is 2. So it's not quite as easy as it is to plot this on a rectangular coordinate system, but since we've got this polar coordinate system, we know that the circle is centered at 0, 2. So that would take us up 2 units. And then the radius is 2, so if I go up 2 units, I've got the top of the circle here, the bottom of the circle here. I don't have really a good place on the polar coordinates to find the left bound and the right bound, but it should be the same distance as the radius of 2. So maybe that's somewhere about here and here. So we'll just try and loop that in the best we can and sort of the circle. Okay, this looks a lot like the last one, and if we multiply both sides by r, then we'll get r squared is equal to negative 2r cosine theta. Okay, so r cosine theta becomes x, and r squared becomes x squared plus y squared. So it's going to be negative 2x. Now I'm going to do the same thing, complete the square. This time I'll have to complete the square on x. So we're going to add the 2x to both sides. So we've got x squared plus 2x plus y squared equals 0. Left a little room here so we can complete the square. So if I take the positive 2, divide by 2, and square it, I get the part I need to add. Okay, so it's going to be plus 1. And then I have to add 1 to the other side. So the perfect square I created here is x plus 2 over 2, so x plus 1 squared plus y squared equals 1. So the center of this circle is negative 1 and 0. And the radius, radius squared is 1, so the radius is 1. Alright, so I've got center of the circle here at negative 1, 0. And the radius is 1 unit, so I know the left bound is here and the right bound is here. Trying to make that look about the same distance. There's our circle. Well, there's our circle.